Okay. Good evening to Sir Vigneswara and my fellow friends. Today we are going to present our assignment for subject Analog Electronic Device BEEE2333. The title of our assignment for this semester is Audio Amplifier Prototype using BJT. My name is Nur Amira binti Abdul Hamid.
My name is Kalila Akila binti Khairuddin.
My name is Nonasrin Shazwani binti Haznan.
My name is Azra binti Azharuddin.
My name is Muhammad Imran bin Huzairi.
Audio amplifier prototype using BTT. Okay, this is the introduction. The other definition of is an electrical instrument that enhance or strengthen an output signal, delivering amplification. There are many types of electronic circuits known as amplifier. It may be small box or block containing the amplifying unit, such as capacitor, transistor, or the field or operational amplifier (OPM), with a much larger output signal than the input signal. An amplifier receives a signal from some pickup introducer or other input source, or provide a large version of the signal to some output device to another amplifier stage. There are two types of bipolar junction transistor or we call it as BJT transistor, such as PNP and NPN. PNP is a 2p type positive charge and one n type which in between these two p type material. For NPN is same theory but the type of layer is vice versa. Each terminal is connected to each layer. The middle layer is called base and the side layer we call it as collector and emitter. One of these PN junction always operate in reverse bias and the other junction operate is called forward bias, which is depend on voltage is applying on which side. Okay. Okay, you can see the PNP and NPN. Okay, for the amplifier has 8 class based on the construction and operation characteristic. The classification of amplifier range from linear operation, which very low efficiency, to non-linear but with higher efficiency, but the other are compromised between the two. The first class is A, B, and C, which is define the length of their conduction state over some portion of the output waveform, such as output stage transistor operation lies between being full on or full off. The second amplifier class is D, E, F, G, S, and T, and so on, which is use digital circuit and pulse width modulation, PWM, to constantly switch the signal between full on and full off, driving the output hard into a transistor saturation and cut-off region. Of conducting angle for class A, B, and C. And this one is conduction angle also, which is class A. We have full cycle 360 of conduction, and class B we have 180. The class AB slightly more than 180 conduction, and class C we have slightly less, 180 conduction, and D to T on and off nonlinear switching. So I will pass the next to Kalila.
Thank you, Amira. Okay, so now I'm going to present for the next part, which cover the component selection in our circuit. We are using multi-sim software to simulate our circuit. We are using version 14.2, and iMultisim is an electronic schematic capture and simulation program. Firstly, as you can see here, we are using one transistor which is 2N3904 NPN type. NPN stands for negative, positive, and negative. In NPN, current flow from emitter to collector. Transmitter is powered on when sufficient current is supplied to base of transistor. The higher current, the more NPN transistor will powered on. Next, we are using resistor. There are 5 resistors here in our circuit, which is 30k ohm, 10k ohm, 5 ohm, 12k ohm, and 33 ohm. A resistor is an electrical component that limits or regulates the flow of electrical current in an electronic circuit. Other than that, we only use one capacitor, which is 1 microfarad. Capacitor is a device for storing electrical energy consisting two conductors in close proximity and insulated from each other. VCC here in our circuit stand for voltage common collector. We use 15 volt of VCC in our circuit. Letter V stands for supply voltage, while CC indicates supply voltage is positive or negative. If positive, the circuit will be negative, positive, negative, while if negative, circuit will be positive, negative, positive. AC voltage stands for alternating current, and it refers to how electrons are moving in an alternating direction in an conductor. DC power or direct current is used in any electronic device with a battery or a power source. Lastly, we have power supply. Power supply is a hardware component that supplies power to an electrical device. It receives power from an electrical outlet and converts current from AC to DC. Thank you.
Thank you, Kalila. Next, I will continue the presentation. Okay, this is DC equivalent circuit. This is a circuit that we construct for audio amplifier using BJT. I am using 15 volt VCC, 5 resistor and BJT bipolar junction transistor. I will run this simulation. So the power that we get from this circuit is 5.141 watt. Okay. This is a calculation that I already simplified. Okay, this is the table for calculated value and measured value comparison for both. Okay, to find the value of RTH is equal to R1, R2. The value that I get is 7500 ohm. Next, find the value of base voltage VB. VB is equal to R2 divided by R1 plus R2 times VCC. The value that I get is 3.75 from the calculate, and from the measured value I get is 3.73 volt. Next, find the value of emitter voltage VE. VE is equal to VB minus VBE. The value that I get is 3.05 volt. Okay. So the measured value I get is 3.103 volt. Okay, next find the value of emitter current IE. IE is equal to VE divided by RE. The value that I get is 254.17 microampere. IC is equal to IE. Okay. The value that I get in this circuit that I measured using multimeter is 258.555 microampere. Next, to find the value of collector voltage VC. VC is equal to VCC minus ICRC. The value that I get is 14.99 volt. Okay, the value that I measured in this simulation, 13.025 volt. It's almost same value that I get in calculation. Next, find the base current IB. IB is equal to 2.70 micro. I'm using current probe here, current 2.70 microampere. Next, find the beta. Beta is equal to IC divided by IB. I get 94.14. RE is equal to 24 milli divided by IE. The value that I get is 102.29. Next, find the voltage gain AV. AV is equal to V out divided by V in. V out is actually from this value that I get in measured 13.025 volt. V in 5. The total that I get is 2.61 volt. Find the power. Power is P equal to I times V. Value that I get is 5.15 watt. So see, it's same wattmeter that I measured in this circuit. Okay, that's all from me. Thank you.
Okay, thank you. Next, I will show the output from the multisim. Okay, now I will show the output from the multisim. We use the wattmeter to measure the power for the circuit. We also use electronic oscilloscope to show the output. So I will run this circuit. So we get 5.141 watt as per request 5 wattmeter. Next, I will show the waveform. So I setting channel 1 is for input and channel 2 is for output. So channel 1 I peak to peak 10 volt. Next, frequency 1 kilohertz. Next, I also channel 2 is for output. Peak to peak 2.9 millivolt and frequency 1000 hertz. So this oscilloscope show the waveform for our circuit and value for peak to peak and frequency. So that's all for waveform. Next. Next, I will present our discussion for our mini project. First, this mini project shows how to make audio amplifier for common use using BJT. We also use multisim software to get 5 watt, and in this project we use a single stage audio amplifier circuit. What we can observe from this mini project is that the RL, resistor load component, is highly useful in this multi-stage circuit for reducing current flow. And when we were focusing on this mini project, there is no output the waveform while we are running the circuit in multisim. This is because we forgot to switch the oscilloscope channel from DC to AC, and after that we get to create this ideal waveform for the circuit. And then we also use formula to determine the value that appear from multisim and the calculation. That's all from me. Next.
I will explain for the conclusion. For the conclusion, the project we are doing was audio amplifier using prototype BGT. It involved audio amplifier for general use. Amplifiers are known as an electronic device that increase an input signal. In other words, they provide the application. An amplifier receives a signal from a pickup transducer or other input source or provide a large version of the signal to some output device or to another amplifier stage. There are also a few components that we use for this project, such as 2N3904 NPN transistor, resistor, capacitor, voltage collector, VCC, and also power supply. We are also able to doing this project accurately by using the NI sim. The result will be same or almost same as the calculation. The result will be same based on calculation and theory value. Thus, the result will be if you accurate if using the real circuit on a breadboard or in the real life, it's because a few factors such as the result will be revealed by the observing the simulated output signal, and the result from the voltmeter reveal the circuit output power value. For
Okay, that's all from us. Thank you.